And let me get an initial screenshot of the attendance. That's good. So let's take a look at this. So solving a quadratic inequality. So just to give you a sneak peek of what we're solving, let's look at this one down here. What we're trying to do is be able to solve quadratic inequalities that look like this. That's where we're going with this. So let's back up here. Solving a quadratic inequality. Here are the steps. Get 0 on one side by itself. Be sure the leading coefficient is positive. That's because for some of the problems you will need to factor, and it's easier to factor with a leading coefficient that's positive than it is to factor an expression with a leading coefficient that is negative. So then after you do this step, you will then want to factor if needed. Not all these steps are going to be needed for each ALEKS question. You want to take your non-zero side and label it with f of x. F of x means y. You want to find the zeros of f of x. The zeros, remember, Z-E-R-O, are x's. They're the x's that make y equal to the number 0. You want to check each 0 in the original inequality, because what you're trying to find ultimately is all the x's that satisfy the original inequality. There will be an infinite number of those x's. And that's why we graph instead of list out an infinite number of ordered pairs. That would take us forever and we still wouldn't be done. So that's why we graph. When we're talking about solving a quadratic inequality, we do it graphically. So we want to check each one of these zeros in our original inequality. If we get a true statement, we want to use a colored in circle, a dot, to plot the 0. If, on the other hand, we get a false statement, you want to use a circle. Circles do not have a middle. We want to use a circle to plot the 0. The circle's just that outside part. And what's going to happen then, after we plot the zeros, you're going to have in ALEKS, you're going to have 3 separate intervals. And you will want to select an x. An x. That's the test point. A test point is actually an x. So this test point right here is actually an x. That's the x that we're talking about here. So you want to select a test point in each interval. You don't want to select these guys. You don't want to select the ones you've done up here. You want to select a test point, and let's say off the boundary. What you're really finding up here with these zeros are the boundary points. You want to select a test point not on the boundary. And then you want to, and you're going to have 3 intervals. So you're going to have 3 x's here. And then you want to test each one of those test points. You want to check in the original inequality, the given inequality. And you want to determine if you've got a true statement or a false statement. If you have a true statement, you want to graph that piece. If you have a false statement, do not graph that piece. Any questions so far? So, and feel free to ask questions. So we're going to do one of the ALEKS topics now. We've got 2 in this document that we are going to do. There are only 2 topics in ALEKS in this objective on solving quadratic inequalities. The first one is not going to use all the steps. It's only going to use some of them. So we want to graph the solution to the following inequality on the number line. Here's our inequality. It's parenthesis x minus 7 times x plus 2 greater than 0. So we want to find all the x's. We want to graph all the x coordinates on this number line which satisfy this inequality. So in our process, get 0 on one side by itself, check, it's already been done. Be sure leading coefficient is positive. This is x times x, which is x squared. That's the leading coefficient. That is, has a positive, understood positive 1 out front, so that's, we don't have to do that. Factor, it's already been factored for us. Next step, label non-zero side with f of x. That's the side that does not contain 0, that we label with f of x. That really stands for y. And then we want to find the zeros of f of x. Here's our f of x. We want to find the zeros. So really what we do when we find zeros is we're taking, to find these zeros, we're taking out this greater than sign temporarily and replacing it by an equal sign. And we're just going to consider this entire side to be y. So we're going to get y equals x minus 7 times x plus 2. And we want to find the zeros. Set each factor equal to 0 and solve for x. And I think by now we know that if we have a factor of x minus 7, that positive 7, the opposite sign, positive 7 is a 0. And for this one, negative 2 is going to be a 0. So our x's, which are our zeros, are 7 and negative 2. Our sheet tells us to check each 0 in the original inequality. Hopefully you copied it down. So we want to check 7 in the original inequality. So these are our x's, so x equals 7. So I want to put it in, that's 7 in for x here and here. So this gives us 7 minus 7 in this first factor, which is inside this red box here, times 7 plus 2 in the second factor, greater than 0. So the question is that a true statement or a false statement? 7 minus 7 is 0. 7 plus 2 is 9. 0 times 9 is 0. Greater than 0. 0. So now we want to ask ourselves, is this statement here true or false? 0 greater than 0, it's false because 0 is actually equal to 0. So because it's false, we want to plot it as an open circle, this open circle here. And really circles are all open. They're just the boundary. So we want to plot at 7, right here. We want to plot an open circle because we got a false statement when we plugged our 0 back into the original inequality. That's what dictates whether this is open or closed, whether you get a false statement or a true statement. That's our boundary. It's the boundary of this array. You could say it's the boundary of these numbers. It's a boundary in a sense. Oh, sorry, we're over here at 7. I got to the wrong place. This is also a boundary. Both of these are boundaries. Both of these open circles are boundaries. And if we check our other 0 in the original, negative 2, we get negative 2 minus 7 times -2 plus 2. -2 minus 7 is -9. -2 plus 2 is 0. -9 times 0 is 0. Greater than 0, that's also a false statement. And so at this boundary point, -2, which is right here, we also want to draw an open circle. So when this is false, you want to draw an open circle. Or actually, you're going to use Alex. You're going to click on this Alex open circle here. And like I said, a circle is just a boundary. So I could just call it a circle. So you want to click on the circle. So this is where you get a false statement, you want to use a circle. Okay, use a circle. Any questions so far? I want to clear up any confusion as I go. I would prefer to do that. So that's why you can feel free to ask questions. You can unmute your mic and just say, I've got a question. I love questions. That's the way I can help students. But I can't help students if I don't, it's hard to help students if I don't know what their questions are. I can anticipate some of them, but I don't know all of them. So at this point, we've got these as our open circles. We don't have this graph or this graph if we were doing this problem from scratch. So what do we do next? Select a test point in each interval. Now those are x's. So if you notice that these two circles, when those are plotted, and if nothing else were there, we would have this interval, and this interval. We would have 3 separate intervals. We need to pick a test point in each one of those 3 intervals. And you will see on your comprehensive final, you will see for one of your written work required problems, you will see this topic or the next topic we're going to talk about, which are both on quadratic inequalities. And for those written work required topics, I'm not really looking at the answers at all. I'm looking for different points of the process. I'm really testing to see if you know all the steps of the process. So you will definitely see one of these. And it could be the next topic we're going to do where you're actually using all steps of the process. So we want to pick a point in this interval right here from -∞ to -2. We want to pick a test point from -2 to 7. And we want to pick a test point from 7 to infinity. Something that's easy to work with. We don't want to pick this endpoint here or this endpoint here. So let's pick -3. Easy to work with. When you can, it's great to pick 0. So we'll pick 0 here. And over here, let's pick 8. And we're testing in the original inequality because that's what we want to graph, the original inequality. So the original inequality, I just rewrote up here, or retyped it in. So let's check. So this test point here, which is an x, let's take this -3 and plug it in here for x and here for x. We get -3 minus 7. When we plug -3 in here, we get -3 plus 2, greater than 0. We want to know if that's true or false. -3 minus 7 is -10. -3 plus 2 is -1. So we have -10, and then we have greater than 0. We have -10 times -1, which is +10, greater than 0. Is it? And then you want to ask yourselves, is it true or false? And 10 is indeed greater than 0. That is true. Test 0. 0 goes in for x here and here, giving us 0 minus 7 in this factor and 0 plus 2 in this factor, greater than 0. 0 minus 7 is just negative 7. 0 plus 2 is just 2, greater than 0. Negative 7 times 2, negative 14, greater than 0. That's false. A negative is always smaller than 0. So this is false, which means we're going to, I shouldn't have used these symbols here because they're not exactly what I want, but I just carried them over from before. But so these were from before, and actually, I don't know if I can get them lined out here, but maybe I'm going to try because they shouldn't have been there. They're not conveying what they need to they're not really, I think I don't want them to distract you. So let me get this red out here and see if I can just click on this and see if I can just kind of go through all of this. That didn't, well, maybe I can just delete them. Maybe that's easier. Yay, look at that. Okay, cool. Those are gone. So we found all of these. We just determined whether we got true or false. True means you want that interval. False means you do not. So we want the interval that contains the test point -3. Where is -3? Right there. So I took this tool in ALEKS, went and clicked in this interval. Click, and that ray automatically appeared. The next interval, the interval with a test point of 0, we got a false, meaning we do not want that interval. So we leave it alone. We don't want this interval with 0 in it. Next one, 8, test point of 8. We got a true. We want the interval in which the point 8 appears. 8 appears in this interval because we got a true. I mean, well, 8 appears in this interval and we got a true. So we want this entire interval. So we go and we click on this and we click in there and get this ray. Any questions? And the important reason we're graphing is because we really have an infinite number of points that satisfy our original inequality. So we can't really list all of those. Any questions on this particular topic? You're welcome to ask questions. So let's go on. That was just, I put a correct sheet there in case I wanted to use it. I have another sheet there. Let's look at, let's look at this one. Let's do this one. I've actually got, from this second topic on quadratic inequalities, I actually have 2 of them, but I just want to do one of them in the interest of time, and particularly this one. This one appears to be where you've got just this one interval in your graph. That seems to be more rare in ALEKS than common. However, it does appear. So we did one with the 2 intervals really for our first problem. So let's do this one for our second topic. So we did the one before for the first topic. There are 2 topics here. Let's do this one for the second topic. And this one should involve all steps of our process. So the first step of solving a quadratic inequality gets 0 on one side by itself. Be sure the leading coefficient is positive. The leading coefficient here is x, first of all, to find it, we want to look for x to the highest power. So this is x squared, x to the first. Constants are degree 0, so it's the squared term. We want We want to keep this, and the squared term has a leading coefficient of -1. That negative is just a -1. So that's a negative leading coefficient. We want it to be positive. So we want to take and move these to the other side. We want to move them over here. I'm going to move them over there. We want to move everything to that side because that will give us a positive leading coefficient. So I just copied down the problem here. So we want to move everything from this side to the other side. The opposite of a negative is a positive. Let's add x squared to both sides. The opposite of a negative is a positive. Let's add 2x to both sides. So we have x squared plus 2x that we're adding to both sides. So let's write in descending power order, but first, negative x squared plus x squared is 0. Negative 2x plus 2x is 0. 0 plus 0 is still 0. Greater than or equal to x squared, we want to write in descending power order, plus 2x minus 3. So now we have 0 on one side by itself, and the leading coefficient is an understood 1, which is positive. Next step, factor. So we're looking for two numbers that multiply to give us 1 times -3 and add to give us 1 times -3 is -3. So the multiply to give us -3 and add to give us 2. Turns out that the factors are x plus 3 times x minus 1. And then I just copied this over and that over. Find the zeros of f of x and label it with f of x, and then find the zeros of this right here. Find the zeros of this, find the zero of this factor and of this factor, and we know that zeros just change the sign, right? So if you have plus 3 here, your 0 is -3 because it gets moved to the other side. We have a -1 here. That's going to get moved to the other side as a +1, so our 0 is +1. So we have our zeros. What do we do with these zeros? We check each 0 in the original inequality. So let's do that. So let's check x equals -3 first. Here's our original inequality. We get negative x squared. Really, that's -1 times x squared. So we want to do the squaring first according to PEMDAS. So we want to take our -3, put it in parentheses, square it, and then put the negative sign out in front. That's the correct order of operations. -2 times x, we're checking x equals -3. So we get -2 times -3 right here. Greater than or equal to this -3. So what do we get here? 2 times -3 means we want -3 times -3, which is +9, but we have a negative out front, so we really have -9. -2 times -2 times -3 is +6, greater than or equal to -3. On the left side, we have -9 plus 6, which is -3, greater than or equal to -3. That is definitely a true statement because so the statement is -3 greater than or equal to -3. So this means -3 is greater than -3, but it also means -3 can be equal to -3. And that's what we have. We have -3 equals -3. So that's a true statement, which means we're going to color in the circle. We're going to use the dot icon. Let's check x equals 1 to see if it's open circle or a colored in dot to see if it's actually a legitimate circle where it has no center? Well, a circle has a center, but the center isn't actually part of the circle. So I want to be clear. It's a little complicated to talk about circles. So we did this one. Let's do x equals 1. So where are we plugging it? We're plugging it in to the original inequality. So we get that up here, negative x squared. So it's 1 squared with the negative out front, minus 2 times x. That would be minus 2 times, we have 1 for x, so the 1's going to go here, greater than or equal to negative 3. 1 squared is 1 times 1, which is 1 with the negative out in front, so that's negative 1, minus 2 times 1, which is 2. So we get minus 2, greater than or equal to negative 3. So we get negative 3 greater than or equal to negative 3. We get it. That's also true because negative 3, this is the equal sign. This is only one part of the equal sign, but it's the equal sign. Negative 3 is equal to negative 3. That is a true statement. So we're going to use the dot, the colored in dot here to plot both of our, what we found, both of our zeros, which were negative 3 and 1. So I'm going to take the dot, put it at our first zero that we talked about, negative 3, right there. Take the dot again, put it at the second zero, 1. And right at this moment, what we have are 3 intervals that we're talking about. We've got our first interval right here. We've got this interval, and we've got our third interval over here. And we have to pick a test point in every one of those, each of those 3 intervals, and test it in the original inequality, the given inequality. We need to pick that number off the boundary. So we can't use this, and we can't use this. Can't use the endpoints now. We need to pick interior to this interval. So let's start over here, going to the left from this colored in dot is negative 4. I put negative 4 for a test point in this column. In this interval here, it contains 0. So I put 0 here. Right here, 2. And then we test in the original inequality, and we're asking ourselves, do we get a true or a false? If we get a true, we want all the numbers in that interval. And we want to use this icon right here. So we've got our original inequality right here. So let's test negative 4. So we've got negative first, and then we're going to put this negative 4 in for x, put parentheses around it, and square it. Minus 2 times x, our x, we're testing negative 4. Greater than or equal to negative 3. And so you need just to work with this. Negative 4 times negative 4 is positive 16. Negative out in front makes it negative 16. Negative times negative is a positive. And so we get positive 2 times 4, which is positive 8. Greater than or equal to negative 3. So negative 16 plus 8 is negative 8. Greater than or equal to negative 3. That is false. Now, if you're having trouble seeing that that's false, there's something that you can do to help you out. And let me just show you what that is. I could move this, I could add 3 to both sides. If I added 3 to both sides here, the 3 would end up over here. Like that. And then I would have greater than or equal to, like that. And we can move this -8 to the other side by adding 8 to both sides. And you could look at it like that. Is 3 greater than or equal to 8? No, it's false. It's false. Okay? So it's either way you get false. Either way you look at it, you get false. So you can move it around like that if you don't like to work with the negatives. Let's test 0. So this time we're going to plug in 0 for x. So we're going to plug 0 in here, but let's write down our negative first. And then 0's going in for x and getting squared before it's getting multiplied by the negative. So this is going to be parentheses 0 squared. I guess we don't really need to write that in, but that's really what it is. And then -2 times, we're plugging in the test point for it, and that's 0, so we get -2 times 0 right here. And then greater than or equal to -3. So we get, on this side, we have 0 for this term, 0 for that term, we just get a 0. Greater than or equal to -3. And again, you could do what we did before. You can move them from side to side if it's clearer to you. So for instance, I could bring the 3 to this, I could add 3 to both sides and have the 3 end up over here. And then I could bring this 0 to this side and have the 0 end up over here. And the question is 3 bigger than or equal to 0? And the answer is yes. Yes, it is. So that gives us a true statement right here. And what about this one? What about 2? What about our third test point, which is a 2? So we do the same thing. We write down the negative sign. Let me make sure I'm in the right place. The negative sign right here. And then in for our test point is a 2, so we take 2 and square it. -2. And our test point's a 2, so -2 times 2. Greater than or equal to -3. So this is 2 squared, which is 4 with a negative sign out front, so it's -4. This is -2 times 2, so it's -4. Greater than or equal to -3. So we get -4 minus 4, which is -8 on this side, greater than or equal to -3. And we had precisely the same thing up here, -8 greater than or equal to -3. And so what we found out about that is that was a false, because even if you did this, it was a false, so you're going to get a false down here too. So the only interval we want only the intervals that have we want to look at only the test points now that have a true associated with them. And the only one we have here is this one. And our test point is 0. So we want to click on the interval that has a 0 in it using this tool right here. So we want to go to the interval with a 0. That's right here. Click inside that interval, and Alex will automatically connect those dots or connect the circles, whichever one you have, dots or circles. Any questions on this one? So I wanted to make sure that I looked at this one with you. You will either get problems, for some of the topic questions you will get, you will either have this interval and this interval or the middle interval. So you want to make sure you can show me detailed written work on the final exam. It's very important that you show your detailed written work for those 7 written work problems. It's better to show too much written work than not enough. And since you know what those problems are, and I give them to you, I do expect you to show all the steps because you know what those problems are. So I'm not, I could say, hey, I'm going to just pick 7 written work required problems and I'm not going to tell you what they are. So you all already know what they are. And so you should be able to show all the steps in those problems. And if you do not show all the steps, I'm not going to give you full credit because I'm not looking for the answers. I'm looking to see if you know the process here. I'm really, the alternative would be to me have you write out the process in words, and really I don't really want you to do that. So I just rather give you a problem to do that. So any questions on this particular topic? So I'm done talking about solving quadratic inequalities. And now I want to take a look at solving systems of linear inequalities. So let's take a look at this particular object. This is I put both of these objectives together into one objective. And I didn't select all the possibilities that I could have put in them. But there are similarities and differences to these. We are still going to talk about boundaries, but it's going to be different. In what we talked about last, these quadratic inequalities, the boundary is -3 and 1. Those are really boundary points, in a sense. So to start talking about systems of linear inequalities, so we're going to talk about, here's a perfect example of a linear inequality. It has an x and y in it. It doesn't have an x squared in it or a y cubed in it. It's a linear inequality. The highest power that appears on an x or a y is an understood 1. Systems means we're going to talk about one topic where we have more than one inequality, and what do we do with that in this context. To get started, we need to talk about how do we determine if an ordered pair, it says for each ordered pair, x comma y, determine whether it is a solution of the inequality 5x minus 8y greater than 13. Why do we look at ordered pairs? Well, let me give you a sneak peek here. I guess I can go right here. We're talking about graphing in the plane here. And every point in the XY coordinate system has an ordered pair associated with it. So that's why we're working with ordered pairs here. So yeah, let me go back here. Let me go back to this first topic on inequalities here. So we're going to look at a couple of the ordered pairs here. If an ordered pair satisfies this given inequality, in other words, if it makes it true, then that ordered pair is a solution and you would answer yes. If the ordered pair makes the inequality false, then to answer the question, is it a solution, you would say no. So let's look at these 2 ordered pairs that I have colored in the circle here and here. Let's look at these 2 ordered pairs and see why we got the answers that I got, or why we will get the answers that I got. So we've got our given inequality. The first ordered pair we're checking is this XY ordered pair, 3, where 3 is the x, and y is -2. And we're going to check it in this inequality. So what we're really going to do here is we are going to take the x3 and plug it in here. And then we're going to take the y, which is right here, -2, and plug it in for y. So we get 5 times this 3 here gets plugged in for x. So we get 5 times 3 minus 8. So we have 5 times 3 from this one, minus 8 from here. And what's going in for y? This -2 right here. -2 goes in for y. Greater than 13. So we want to know if that's a true statement or a false statement. So 5 times 3, 15. Negative times a negative, positive. 8 times 2, 16. Greater than 13. 15 plus 16 is 31. Greater than 13, absolutely true. That means our ordered pair, 3, -2, is indeed a solution. So we check yes, or we color in the circle with a yes above it. So we're going to color this in. I colored that in. Any questions? This becomes a very important piece of when we graph a system of 2 linear inequalities. For that matter, when we graph a system of 1 linear inequality. So let's look at our other order pair, -7, -6. Same idea. The first coordinate is our x coordinate. The second coordinate is our y coordinate. So this would be 5, copied down. Our x is -7. So -7 is going to go in for x this time. Minus 8 times y. Our y for in this is -6. So the -6 is going in for this y. Greater than 13. True or false? Positive times a negative, negative. 5 times 7, 35. Negative times negative, positive. 8 times 6, 48. Greater than 13. -35 plus 48 is 13. Greater than 13, false. It's not, 13 isn't greater than 13. It's actually 13 is equal to 13. And there's no equal indicator here at all. So this is false. So for -7, -6, we get a false, which means that ordered pair is not a solution. So to answer this question, is it a solution? The answer is no. So for -7, -6, we wanted to click in that circle. Any questions on this particular topic about identifying solutions to linear inequalities in 2 variables? Let's start looking at graphing linear inequalities. And you can get a sense for what we are doing here. It's just like what we did earlier today. We first want to find the boundary, the endpoints. But when we're talking in an XY coordinate system like this, we're talking about there's lots of boundary points, not just one like we saw with quadratic inequalities. There's lots of boundary points, all the ones along this dashed line. There's an infinite number of those. So how do we go about graphing? We want to graph the inequality y greater than 1/2 x plus 4. How do we go about graphing? First, we need to find the boundary, and then we're going to select a test point. This one, if you notice the boundary, which is dashed in here, separates the plane into 2 separate regions. This one and this one. And that's because we only have one boundary line here. It happens to be dashed, but that's what happens when you have only one boundary line. If you had two boundary lines, which we're going to see today, it's going to separate the region it's going to separate the plane into 4 regions. And you go on from there. If you're planning on going on to finite math, you will definitely see this because they're going to spend a good deal of time talking about linear programming problems and the simplex method. So it's very important to understand if you're going to go on to finite math. So we want to find the boundary first, just like we did earlier today. Replace the inequality by an equal sign. So here's our original inequality. So we want to take that out, that inequality, the original inequality, and replace it by an equal sign. So our boundary is actually y equals. We're putting in an equals here temporarily just to get the boundary. So y equals 1/2 x plus 4. That's our boundary. And we are going to graph our boundary as a dashed line. Why are we going to do it as a dashed line? Because we have a greater than sign or a less than sign. We do not have the equal indicator. So we graph, when we have a greater than sign or a less than sign, we graph the boundary as a dashed line. The boundary is only graphed as a solid line if this original inequality here included an equal sign. The boundaries where the boundary we are going to get is where y is equal to 1/2 x plus 4. That y equals 1/2 x plus 4 is actually the equation of the boundary line. And since we don't have an equal indicator here, we're going to graph it at our boundary as a dashed line, because we're in this case where we have a greater than or equal to a greater than sign. So if you have no equal indicator, that means a dashed line. And that's what we have. So keep in mind, we want to use a dashed line. Here's our boundary. We took out the inequality and put in an equal sign in its place. Everything else is the same. We are graphing a boundary. The boundary is a line. 2 points determine a line. It's usually easiest to put 0 in for x and 0 in for y. Not always, but usually. So let's put 0 in for x. If I put 0 in for x here, we get 0 times 1/2, which is 0, plus 4 is 4. So we're going to have y equals 4. So I put 4 in for y. If you put 0 in for y, this entire side is 0, we get 0 equals 1/2 x plus 4. 1/2 x equals 1/2 x plus 4. And we want to solve for x. Let's move the 4. Subtract 4 from both sides. Then we'll go and we'll get -4 on that side. Equals 1/2 x. The opposite of dividing by 2 is multiplying by 2. So let's multiply both sides by 2. -4 times 2, -8. Equals, the 2's cancel, and we just get x. So our x equals -8. So those are the ordered pairs for 2 points on our boundary line. So we can now plot those. Let's plot 0, 4. So 0, 4, x coordinate of 0, y coordinate of 4 is right there, right where that colored in circle is. Then -8, 0 is the other ordered pair. Let's find that point. -8, 0. -8 on the x, we start at the origin, go -8 in this direction, and then 0 means, for the y, means to stay put, so that's where we stay, and then we put a point there. And we know we want to dash, we've got two points which determine a line, and we know we want it dashed in because there's no equal indicator. So we're going to, after we plot these 2 points, you can use the point plotting tool, the pencil, to do it, or the plot anywhere tool, whatever you choose. Then you want to use the line connector tool here. It's in all likelihood going to make it solid. That seems to be the default for Alex. So if you want to convert a solid line to a dashed line, you use this tool here, which has a solid on one side and a dash on the dashed. It has a solid curve on one side, or a line, and it has a dash curve on the other. So you just click on that and it will change. Well, you click on your line. You click on this and then the line, and it will change it from solid to dashed for you, or dashed to solid for you. So that's how you find the boundary line. Very important. And then what's nice about this theory is now this boundary line here splits the XY coordinate system into 2 regions, this up here and this below it. So you now need to just choose which one of these 2 regions is going to, that you want to shade. And so the way we do that is we just pick a test point. The test point, again, cannot be on the boundary. Most of the time we use 0, 0, the origin. However, you cannot use 0, 0 if your boundary line goes through the origin. Cannot use it then. Here, our boundary line does not go through the origin, so we can use 0, 0 as our test point to figure out which region we need to shade. So you want a test point that's not on the boundary. 0, 0 does not work in all cases. In a lot of cases it does, but not every case. And it's easy. It's pretty easy to get caught in a rhythm and always using 0, 0. And it's just about then when it comes back to haunt me when I do that. I really have to think about it to think, is my boundary line going through 0, 0? If it is, I cannot use 0, 0. So you want to select a test point not on the boundary. In this case, we can use 0, 0, and we want to go back to the given inequality. That's what we're trying to graph. So we want to go back there. So the given inequality, let's see. Let's test it in the original inequality and see what happens. So we're testing 0, x is 0, y is 0, so it's not too bad to test. So let's do that. So we know we're testing both x equals 0 and y equals 0. So we plug in 0 for y, get 0 is greater than 1/2 times 0 plus 4. So 0 is greater than 1/2, 0, 1/2 times 0 plus 4. 0 is greater than 1/2 times 0 plus 4. And now if we figure out what this is, we've got 0 on this side is greater than 1/2 times 0 is 0, since any number times 0 is 0, plus 4 just gives us 4. 0 greater than 4 is a false statement. So we want to, that means when we get a false statement, we want to shade the region that does not contain the test point. We want to shade the other. So our test point is 0, 0. 0, 0 is right here. We got a false. That means we want to shade the other side of the boundary, which is over here. So we want to shade this. So this is the region shade tool right here. It almost looks like a quadrant if you look at it. If you turn your head a certain way, it looks like 4 quadrants. So that's the region shade tool. So I want to shade this region right above the boundary line. Sorry, I think somebody just turned on the water, so I'm trying to move around back in my room from it so I can get away as far away from it as possible. So that's why we shade this one up here. because we got a false down here. So we want to shade the side of the boundary that the other side of the boundary that's away from 0, 0. Any questions on this particular inequality, graphing this inequality? So if you notice, this is in mx plus b form here. Now, let's look at this one. So there's another topic in this objective, which is going to have you look at either x less than or x less than or equal to, greater than or equal to, less than or equal to a number. And then they're going to do the same thing, but with y. So it's important to remember vertical and horizontal lines. A vertical line is x equals a number. A horizontal line is y equals a number. So we use the same process. We first want to graph the boundary line. So I copy down the problem here, x greater than or equal to 7. We want to graph the boundary. To get the boundary, we take out the inequality symbol, we replace it by an equal sign. Very important part of the step. That's a very important step. So our boundary is the equation of our boundary is we take this out, we put an equal sign, so we get x equals 7. That's the equation of our boundary. Now x equals 7, if you remember back and quite a long time ago in the course, that represents a vertical line. It is what this represents is it means all x's, every single x has to be 7. So you have to have 7 comma something, 7 comma something, 7 comma something, 7 comma something, and so forth and so on and so on. Every single x coordinate has to be 7 in this case. But since we're graphing a line, 2 points determine a line, we only need 2 ordered pairs. So we're going to put 7 in for the x, since our x coordinate has to be 7, we're going to put 7 in for x for 2 in the first spot in 2 ordered pairs. What we choose for y doesn't matter. Let's choose nice numbers, 0 and 1. If you were to graph this now, let's go ahead and graph 7, 0 and 7, 1. 7, so we start at the origin. That x being 7 means we go 7 in the positive direction. We're going to end up here. And this 0 down here means to stay put. So we start at the origin. We go to 7. The 0 means to stay put, and you'll see I put a little point right there. This 7, 1, we start at the origin. We go 7 in the positive x direction. And then 1 for y means we go up 1. And I put a little point right there. 2 points determine a line. So and let's not get ahead of ourselves. We do have the equal indicator here. We do have this equal indicator here. So that means we've got equals. So that means that we've got the equal indicator. So we want to graph our line as solid, not dash, solid. And that's because you've got the one piece of the equal sign right there. That's what you can look at that as. So we've got we're going to graph as a solid line. So we're just going to click on this, go click on this point, click on this point, and it will draw the graph for you. So we've got our boundary. Our boundary is our boundary is x equals 7. It's a vertical line. So at this point, imagine we don't even have the shaded region here yet. What do we do? So the first big piece of this is all about the boundary. The next piece of it is determining which region or regions, depending on how, we're going to see that later. Which region do you shade? We're just going to shade one region in any of the topics that we're going to do today. But we're going to see 2 inequalities later, and we're going to have to pick one out of 4 regions to shade. So after you're done getting the boundary, we just have to decide, are we going to shade this region or are we going to shade this region? And we need to choose a test point. And guess which test point we're going to choose? 0, 0, because it's not on the boundary. So you want to choose a test point not on the boundary. We're going to choose 0, 0. Test in the given inequality. So we want to go we want to make sure we're testing in this inequality, the given inequality, x greater than or equal to -7. So we want to check our 0 in there. So we're talking about x here. What goes in for x? Whatever's the x coordinate here, which is 0. Greater than or equal to 7. Is 0 greater than or equal to 7? Is that true or false? 0 greater than or equal to 7 is definitely false. So we want to shade the region that does not contain the test point. We want to shade the region that does not contain 0, 0. This region over here contains 0, 0. This is the other one. It does not contain 0, 0. So this is the one that we want to shade. Can you all hear the water, or are you good? Can somebody tell me, can you hear the water running? Can somebody let me know, yes or no?
I can't hear it.
Good, good. Okay, great, great. Can anybody hear the water running? I want to make sure you're all.
I don't hear it.
That's great. Thank you. Thank you for your feedback. Any questions on this particular problem or topic? Both a topic and a problem. So let's go on. If you ever hear something that I can say something to someone in our house, I'll be glad to do it because I want you all to hear clearly. And I'm sure you all understand it's what we're living in now. You have no idea. You can't what's gonna go on. So anyway, let's look at this topic. Another topic here, separate one. Let's look at graphing this inequality here. -x minus 3y less than -3. Process is exactly the same as we have been using. Find the boundary first, and then determine which region to shade. So I just copied this down. Exactly. Put it right here. We want to find our boundary first. So we take out the inequality symbol and really let me just read these words. Replace the inequality symbol with an equal sign just to find the boundary. And we'll go back to this when we decide on the region. So we get -x minus 3y. We're taking out the inequality symbol, replacing it with an equal sign. Equals -3. And we're going to find our boundary is linear, so we need 2 points. So let's find them. Let's put 0 in for x for this one and 0 in for y for this one. So if I put in 0 for x here, we're covering this up. So we can ignore it because if we put 0 in for x, we get 0. Negative of 0 is still 0. We can cover this up. And then we're just looking at -3y equals -3. If we divide both sides now by -3, we get -3y divided by -3, which is just 1y, which is y. If we divide the other side by that -3 by -3, we just get 1. So we get y equals 1, and hence the 1 in the y position. Let's now put 0 in for y. 0 times -3 is still 0. So imagine covering this up now. We do have cover-up rules in math. So we want to cover this up. We're left with -x equals -3. If we just multiply by both sides by a negative, this negative is going to switch to a positive. This one's going to switch to a positive, and we're just going to have x equals 3. So those are our two points on our boundary. So let's plot both of those. Let's look at plotting both of those points, 0, 1 and 3, 0. So 0, 1, start at 0. 0 for x means we stay put, and then 1 for y means we go up 1. And there's our point. The other point, let's start at the origin, 3, 0. The x is 3, so we're going to move 3 in the positive x direction. That takes us there. And then our y is 0, which means we stay put. So there's our point. Now our boundary is dashed because there's no equal indicator here. We do not have less than or equal to. And so that's the reason for the dashed here. So you want to take this line tool, click on this point, click on this point. Then you want to, in all likelihood, use this tool here, which changes from solid to dashed. You want to click on your line when you do that. So it changes from solid to dashed. Any questions on getting the boundary? Let's look at selecting the region. So we definitely have to use our given inequality at some point. We want to find the region for this inequality. So let's use it. So we're now going to select a test point, and 0, 0 is not on the boundary, so we can select it. So let's use 0, 0. And we're going to test in the original inequality, which is right here. Let me just make sure of that. -x minus 3y, and that would be less than -3. So here's our original inequality right here. If we put in 0 for x, we get -0 minus 3. Here's y, here's our test point, and in our test point, y is 0. So we put in 0. Less than -3. Less than -3. So on this side, we get -0, which is 0, minus 3 times 0, which is 0. -0 minus 0 is 0, less than -3. That's false. Now, one little trick you can do if you don't like it like this, what you can do, which sometimes is helpful for me if I want to double check, is I could add 3 to both sides, get my 3 on this side, and then I could put down the less than sign, and then I could add 0 to both sides, so the 0 would end up over here. So it's all a matter of which one tells you what you need to know there. Let me get my 0 here. Made a little error there, but that's okay. So we got 3 less than 0. Maybe that's better for you. 3, that means a positive number is smaller than 0, and that is false. Any questions on that? So we got a false when we checked our test point. That means we want the other side of the boundary that does not contain the test point. So we checked 0, 0. We got a false, and that's down here. So we want the other side of the boundary, which is up here. So we want to use our boundary shade tool by taking this icon here and clicking in here. Make sense? Any questions on this particular topic? And now that brings us to the last topic of the day. And this one will take a fair amount of work. You can see I've got it indicated as page 1 of 3. Okay. If you can hear the water at any time, any of you, please speak out. Don't be, I'm fine with getting up for a minute or two and going, and I'm guessing it's my husband's got the water turned on somewhere. So I'm fine with doing that because I want you all to learn. That's what I'm here for, and that's a very, very, very high priority of mine. So let's take a look. Graph the solution to the following system. So we have a system of inequalities when 2 or more inequalities are involved. So this is going to come up in linear programming problems in finite math, and you will probably see more than 2 inequalities. So it's important to understand how to graph 2 inequalities, like inside, outside, upside down. If to be Dr. Seussish, especially if you're going on to finite math, they will only build on this. So let's take a look. So the process is pretty much the same. We're still going to graph our boundaries first, but because we have 2 inequalities and there's 1 boundary per each inequality, we're going to have 2 boundary lines. And to give you a sneak peek of these 2 boundary lines, there you are. We're going to have one that's dashed and one that's solid in this problem. That doesn't mean that's how it's going to happen for all of them. We have one that's solid because the equal indicator appears. We have one that's dashed because the equal indicator does not appear. You could have 2 solids or 2 dashes, or one of each. So that's what we're looking at. And you can see we're going to have 4 regions here. And you may be wondering, how do we determine which region? And that's why I needed quite a bit of time to talk about this one topic. So going back here, let's start by copying these down. Y is less than or equal to 4x minus 7. Y is less than or equal to 4x minus 7. This less than or equal to, that one right here, that's really, I would encourage you to think of that as the top part of the equal sign. And then I copied down my other inequality, y is greater than negative 3x minus 2, right here. And the way we usually do these is write them across this way, because in finite math, you could have, like, say, x greater than or equal to 0 down here and y less than 0 down here. So you want to keep them all going across. Otherwise, it gets pretty confusing on the paper where everything is. Whereas if you're always putting your inequalities in the inequality column, your equation for your boundaries in a column, and your points that your ordered pairs that you're going to use to graph the boundary over here, and whether they're solid or dashed over here, it's nice and organized. So let's take a look at our first boundary. Let's find the equation for the boundary, and let's find 2 ordered pairs associated with points on the boundary, and let's determine whether we're talking about solid or dashed. So our first inequality, we're going to take out the inequality symbol and replace it by an equal sign to get the equation of the boundary. So that would give us y equals 4x minus 7. And then we're going to test 0, 0. We're going to use 0, 0 since we're just graphing the boundary line at this point. We're not trying to select the region yet. Okay, we're just graphing the boundary. So let's put in 0 for both. If we put in 0 for, oh, actually we got to do them one at a time. And I have this, I've got a 0 here and here. And I think I was talking about something else at the time with my previous class. Now I remember what I was doing. And let me turn on this. And let me see if I can erase this one right here. We want to put, let's erase this. So I'm going to put in 0 for x first. We got x equals 0 here. So put in 0 for x. 4 times 0 is 0, minus 7 is negative 7. So y is going to be equal to negative 7. Let's do the other one. Let me get the eraser. Let's do the other one. Yeah, I don't have it. Got to be careful with that eraser. Never know what it's going to grab. Can't go big. I have to go low here a little bit. And then I want to put a 0 over here this time. I think it'll work this time. There we go. So we now want to put 0 in for y over here and solve for x. So if we put 0 in for y, we're going to get 0 equals 4x minus 7. So we're going to have to solve this one for x. So let's put the 7 on the other side. It's going to go over there as a positive 7. We're going to get 7 equals 4x. And then we want to divide both sides by 4. 4 divided by 4 is 1 times x is x. 7 divided by 4 is 7/4. So our x is going to be 7/4. Are we going to graph our boundary as solid or dashed here? This has the equal indicator. That's what controls whether it's solid or dashed. So it's going to be solid. If your inequality symbol has that equal indicator, your boundary is going to be solid. So I put S for solid. So let's look at our next one there. I'm going to take this out because I want to put these notes in your course, in your ALEKS course for you. Let's look at the next one. If we're going to take, here's our inequality. Let's take the inequality symbol out and replace it by an equal sign to get y equals negative 3x minus 2. We are first going to put 0 in for x. So let's get rid of this. So what are we going to get if we put 0 in for x? We are going to get negative 3 times 0, which is 0 minus 2, which is negative 2. So y is then going to be negative 2. So if we take this out now, and we see if I can click on this, and then just kind of trick it here. We want to get rid of this, and then we want to put in 0 on this other side. We are now putting in 0 for y. So we get 0 here equals negative 3x minus 2. Solve for x. So we want to add 2 to both sides. That'll put the 2 over here, leaving us with just negative 3x. Now we want to divide both sides by negative 3 to get x by itself. And if we divide this side by negative 3, we're going to have negative 3 divided by negative 3, which is 1 times x, which is x. And then This side, we want to divide by -3. So we're going to have 2 divided by -3. So we can put the negative out in front, and then we're going to have 2 divided by 3. So our x is -2/3. So our x is -2/3. Before I forget, let me take this out. Now we want to determine if we're going to have a solid line or a dashed line. That all boils down to the equal indicator and whether you have it or not. Here we had an equal indicator. Here we do not have an equal indicator. When we have the equal indicator, that's solid. That's solid. So this will happen if you've got less than or equal to. Or greater than or equal to. This will happen. You'll have dash if you've got less than or greater than. And we have greater than. So we're going to have dashed here. Here we have less than or equal to. So we have solid. Any questions on that? So let's just graph. Guess I graphed on the next page. So let me write down these ordered pairs. So 4, I'm going to write this down, just jot it down so we can see, and you might want to jot it down as well. I'm just jotting down the inequalities and the ordered pairs that go with them. So that's what I'm going to look at because I want to show you that. 0, -7, and then 7, 4, 0. And then the next one, and the 2 ordered pairs are 0, -2, and -2/3, 0. Solid, dashed. I did my S and my D as well. So let's go on, unless you need more time. So let's take a look here. So let's plot the boundary for the first boundary we got is solid, and our ordered pairs are 0, -7. So here's the y-axis. This is the x-axis. So 0, -7 looks like it's right about there. 0, -7. And then we want 7, 4, 0. So to help you out when Alex will help you out. So you really don't need to do that. You could, because you can use this tool. But for purposes of this, I'm going to take 7 divided by 4. I get 1.75. So we get 1.75. We start at the origin. 1.75 is about right here. And then 0. So that totally makes sense there. We had a point down here and a point up here. This is solid. So that's the reason for that solid line. Then our other boundary line, we found an ordered pair of 0, -2. So here's 0, -2. We're going to, it's somewhere right about here. 0, -2 looks like it's about right there. And then -2/3, 0, which is -0.67. So that would be just a hair to the left here of right there. And that turned out to be a dashed line. So you want to click you want to plot your points, and then you want, when you how you plot them, and then this tool will be involved, and you want to click there and layer on your points. And then if you want to convert to dashed, you want to use this icon right here, which is converts between solid and dashed. And we're left here now with 4 regions. This region, which is the answer, this region, this region, this region. So let me just take a peek here. Yep. So what I usually do is I have a 0, 0 is here. I usually do something like this. I decide whether I'm going to have a strategy, which 0, 0 actually is in here. So usually I'm going to go counterclockwise around and always do it that way so that I have a strategy that I'm using all the time. I find it keeps me more accurate. So I've got 1, 2, 3, 4 regions there. So we're going to start with 0, 0. Turns out that none of our boundaries don't go through 0, 0. I can verify that for you, but first of all, the boundary points that we found did not go through 0, 0, and we involved zeros in them. If you're still not convinced enough, I can work with you after class and show you why we don't have any boundary, or we don't have it. That I can show you why the boundaries do not go through 0, 0. You will have a big graph when you're working in ALEKS. You'll be able to see more clearly. That's what I feel. So let's first start by choosing a test point in a particular region. If you can, I would start with 0, 0. And let's start with 0, 0. And I copied over our two given inequalities right here. Let's start with 0, 0. Let's go back for the graph for a moment. I just remembered something I want to say. Whatever test point you use must satisfy both inequalities simultaneously. That means that test point must, and that consists of 2 coordinates, that test point must satisfy both inequalities at the same time. And there will only be one region. So we're going to start with 0, 0. And here are our 2 inequalities. So here's our test point, 0, 0. So here's y. So we're going to put 0. In this case, our x is 0 and our y is 0. That's why I like to start with this one. Unless one of the boundaries goes through 0, 0, in which case we can't start with it. So our y is 0. Put 0 in for y. So that would mean 0 would go on this left side here. Less than or equal to 4 times x. We're testing this as our test point, and in our test point, x is 0. Minus 7. Minus 7. So over here, we just have 0 on the left side, less than or equal to. 4 times 0 is 0. Minus 7 is negative 7. Is that true or false? Well, 0 is, I mean, if you don't like it this way, you can turn it around and write it the other way. So for instance, you can add 7 to both sides, in which case the 7's going to end up over here. You can also, and I'm going to put less than or equal to here. It's less than or equal to. Make it a little better. So we've got less than or equal to. I'm just going to leave it because we would less than or equal to. And you can move this 0 to the other side, subtract 0 from both sides, add 0 to both sides, however you want to do it, and that's going to end up over here. Now, if you look at it that way, is 7 less than or equal to 0? Is 7 smaller than 0 or equal to 0? No, it's bigger. So that's a false statement. A false statement. So we get a false statement. Well, in order for us to shade in that region, if we were to shade in that region, we would have to have our test point satisfy not one of these inequalities, but both of them. It doesn't satisfy the first one, so we can quit. We're not going to select this region. We can quit just with this test point. Not with the whole problem, just with this test point. So we move on. If you get one false, you move on. Because both of these, you have to get both trues. Get one false, move on. So then we know this, we are not going to select the region with 0, 0. So we go look at our graph and pick another test point in a different region. So we're going around this way. Let's pick -2 here. So we're going to use -2, 0. So let's pick -2, 0. Now let's test. Let's test in our first inequality. And that would be y. Well, for this test point, y is 0. Less than or equal to, copy over. 4, copy over. X. Our x here is -2. 4 times x will be 4 times -2. Minus this 7. So we get 0 on this side. Less than or equal to 4 times -2 is, we got our 0 over here. 4 times -2 is -8, minus 7 is -15. 0 less than -15. And again, if you don't like it in that form, you can switch sides. But you got to be careful. So if I add this to both, add 15 to both sides, the 15 will end up on this side. And then less than or equal to 0 will end up over here. Is 15 less than or equal to 0? That's false. That's false. So if you need to switch them, please switch them. That's false. So we're not going to select the region with -2, 0 in it. So I purposely wanted to do a problem where I had to go through all the regions so you could see what would happen. So we have to move on to another region. So now we're in this third region here, and I believe I selected -10, 0. Let me see. Nope, 0, -10. I knew it, I had the numbers right. 0, -10. So we went here. Oh, that makes sense. So we first did this region. Then we did this region. All of this, we just did all of this. And now we're down here. So I selected 0, -10. And let's test this. Do it the same way. So we have a y. Our y for this test point, -10. Less than or equal to 4x. Less than or equal to 4. Our x coordinate is 0. And then -7. So we just have -10 on this side, less than or equal to. 4 times 0 is 0, minus 7 is -7 over here. Is that a true statement or a false statement? you can always draw a number line. And this -10 is smaller than -7 because -10 lies to the left of -7 on the number line. So that is a true statement. So we got one true statement. So there's hope there. So we need to go on. We need to assume this is a possibility at this point. So we want to test. We want to test the second inequality now. The first inequality, when you get a true for the first inequality, you want to then test the second inequality using the same test point. So our second inequality is y. Y is -10. It's greater than in this setting, in this inequality, -3x minus 2. -3, our x in this particular, for this particular test point is 3. And then we have a -2 tacked in. Wait, I think I got ahead of myself. Sorry about that. I think I was doing this one. I did this one. So let me make sure we could do this one right. Oh, I've got them right here. Very, very, very good. Okay, so we tested this, got the true. Now, we got to use this test point again, but this time we're going to use it in the second inequality. And our second inequality says we want a y. Our y is -10, greater than -3, copied over, x, our x is 0. And then -2. And we have to work this out. So we get -10 on this side, greater than a sign, and then this is -3 times, -3 times 0, which is 0, -2 is -2. Now we want to know if that is true or false. And I should have done this because you can check these, like I was saying before. I can move this -10 over to the other side. So I can put a greater than symbol here and I can move that -10 to the other side by adding 10 to both sides. And I can move that -2 to the other side by adding 2 to both sides. And then I get 2 greater than 10. Well, that certainly is not true. That's false. And we could have done that over here too. We could have moved that 7 to the other side. And let me get that sharp corner there. And then we could have, and that would have been less than on the less than or equal to. And then we could have moved this -10 over by adding 10 to both sides. So it might be easier for you to tell whether you've got true or false doing it that way. So in the first, up here we have 7 less than or equal to 10 is certainly true. Here we have 2 greater than 10, false. So we ran into a problem here. So since we ran into a problem here, this is not that we do not want to select the region with this test point. So we move on. So we move on to the fourth region. So the fourth region, we select a test point in this region now, and I selected 4, 0. So when we look and do all of this selected 3, 0, selected 3, 0, and when we do this process for 3, 0, you will notice ultimately I got 0 less than or equal to 5, which is a true. And for the second inequality, I got 0 greater than -11, which is also true. And you can turn this one around and write it the other way. You can write this one the other way if you want. You can put the 11 on this side. The opposite of negative is positive. And you can put the 0 on this side, 0 11 bigger than 0, that's true. 0 less than or equal to 5, that's true. Both of them are true. So we want to shade the region which has the test point of 3, 0. 3, 0 is right about there. Right about there. So we want maybe right there, somewhere around there. So we want to shade that region. Anybody have any questions on today's objective? So I've finished up, and I think hopefully you all have a much better idea about how to deal with this last topic. So if you have 2 inequalities and you get 1 false, you get the first one false, you can stop and go to the next region. Stop and go to the next region, and so forth. Just like we did today. You may be lucky and the first point that you choose for your test point, it may work for both inequalities. I wanted to do one where you saw how to go about dealing with it if you had to go through all 4, you had to go to the 4th region to get a test point. So I think I've done that. So I'll come back up to you all now, and I will say my goodbyes, and let me make sure I'm taking attendance here. Good. I'm looking at seeing who is in this meeting, and that's good. I think maybe, oh, that's good, Blair. Thank you. I feel better now. I'm gonna have a little chat with my husband about that. So yeah, I heard it pretty loud and clear, to be honest with you. Anyway, well, I want you all to have a nice weekend, and we do have remote classes on both Tuesday and Thursday of next week. We will be talking primarily about systems of equations. So goodbye for now. Take care and have a great weekend. Thank you, Jacob, for yes, the semester flew by, didn't it? Hey, yes, thank you, Blair. Have a good weekend, everybody. Reach out to me if you need help. Bye for now. And if you want to stick around and chat, you're more than welcome to. Courtney, do you have any questions?